for the different drawdowns and whatnot. And from then, since we're talking about, so this was related to sand production, right? Which again, sand production are breakouts that occur during production. Okay. So you can then look at, those finite element simulations are expensive, but what you can do is then say run a series of them and then kind of interpolate in between. And this would be like one way that you could look at it. So what you're looking at here is if you looked at the bottom hole pressure versus reservoir pressure, only below this line would you be producing anything, right? If your bottom hole pressure has to be below your reservoir pressure for you to produce something, right? So nothing's happening above it. But then below the line, then you can then plot with different models what you'd expect to see. So this is at an unconfined compressive strength of 1,000 psi, at 1,600 psi, and at 1,800 psi. And the difference between the vertical line, the diagonal line where you're producing it all, and these lines would be the sand-free drawdown, right? So everything to, if you have a rock that has an unconfined compressive strength of 1,000 psi, anything in here would be a sand-free, you wouldn't produce sand. Right? And then likewise, the stronger the rock you get, then you increase that region of sand-free production. And obviously, I think you guys know why sand production is bad, right? Because you can't sell sand. You can't just put it in the pipe and sell it. You have to work, clean it up. These are just more of the same. So you can actually look to minimize sand production with different perforation orientations. So, like for example, in a vertical well, we know breakouts are going to occur at the azimuth of SH min. So let's not perforate right there at the azimuth of SH min to weaken the rock that's already in peril just due to the stress state of the earth, right? So if you can orient your perforations differently. So in this plot, they have, again, your plastic strain, that measure that comes from a more complex model than what we've looked at. But your plastic strain as a function of wellbore deviation for vertical and horizontal perforations, and then using this black dark line at 4% equivalent plastic strain there as your sort of it's still kind of empirical, but it's better than anything else to say that anything greater than 4%, we're going to expect a lot of sand production from that well, right? And then anything less. So you can see in this case, if you perforate vertically for any angle of deviation, then you're safe, right? But if you perforate horizontally, then if you go past 30 degrees of deviation, then you're going to expect a lot of sand production. So again, this was, these are tied to one reservoir, but nevertheless, these are different ways you can look at these things to get some indication of what's going on. So this was something similar, except now it's plotted where instead of just looking at vertical and horizontal, you have on this axis perforation angle from vertical. So as you sweep around in degrees from vertical, again with the 4% simulated plastic strain criterion, and these are the two different sort of drawdown scenarios. But nevertheless, you see for small angles from vertical, you're safe. But if you go too large from vertical, which 90 would be horizontal, then you're going to be in this danger zone. And the depletion rate does matter a little bit, right? But anyway, just a couple of different ways to look at these things. So those were only looking at deviated wells. This is also it's more of the same thing. Also looking at the azimuth of drilling, right? Bottom hole pressure versus reservoir pressure for different azimuths of drilling. So up here, no sand production. Down there, you'd expect sand production. So these are all things you consider. And I think just in summary, in this Cook Inlet case study where they looked at all of these things to determine should they case the wells or not, they ended up determining that the wells should be fully cased because there was just too big a risk from breakouts during drilling and also during production, sand production. So they decided to case the wells fully. But of course, if you could run these type of analysis and make the decision not to case them, that's a large savings. So it's useful to have these kind of tools available.